Hi, I'm Sami Kuba.
And I'm Kelly Akins, Program Manager for Incident Readiness.
And I run the Azure Communications team. Our team communicates to customers during impacting events. This could be a maintenance, a retirement of a feature or a service, or in worst cases, an impacting incident. Now, these incidents are inevitable, but impact to customers doesn't have to be. These sessions will walk customers through parts of our well-architected framework, whether it's taking advantage of the resiliency options that Azure makes available to customers, or the best practices for your application once they've migrated from on-prem into the cloud, or even troubleshooting your environment.
That's right. So we're here to translate those readiness recommendations into practical, actionable solutions to help you prepare for the unexpected, with our ultimate goal of helping you minimize or even prevent the impact of incidents. So we hope you enjoy the conversation. Thank you. So today we'll be covering how to build and operate reliable and resilient critical workloads. You'll learn how to find out which resources are impacted, whether it's because of a planned or unplanned event. And then last but not least, you'll learn how to be more prepared, how to respond, and how to protect your Azure resources against the latest security threats. So with all of that being said, I'd love to bring in my co-host, Sami. Sami?
Super. Thank you very much, Kelly. My name is Sami Kuba. I run the Azure Incident Communications team. This is the team that communicates to customers during impacting events. These events could be a retirement of a feature or a service. It could be a maintenance event, or in worst case, it could be an outage. Now, just before we start, I'd like to remind everyone our Q&A is open. We have SMEs who are standing by to answer questions, so please hit the Q&A button and ask away. The purpose of these sessions, as Kelly alluded to, is to pass on the idea that while outages are inevitable, impact doesn't always have to be. And it's with that we kind of speak to our customers about having a shared responsibility as customers move to the cloud. And as we think about this kind of shared responsibility, we take the idea that Microsoft Azure has a role to play. And the best way to kind of look at this graph at the moment is from the bottom up. And there's things that we're going to do to protect our platform and make sure that it's reliable and durable. But where it gets really interesting is that middle tier, because the middle tier offers customers the resiliency levers that they may need. So customers need to kind of find out which of their workloads they need to make reliable, and they can pull some of the levers there. Then, of course, at the very top, customers have their own application. We don't have anything there that we can help with. But as I kind of conclude with that, Kelly, do you want to speak about how Azure works in the context of geographies, regions, and availability zones?
Yeah, thanks so much, Sami. So before I jump into the content of these slides, and before we jump into Dave's demo on building and operating reliable and resilient critical workloads, I wanted to take a pause and talk about some Azure key building blocks like geographies, regions, and availability zones. These concepts are really important for you to understand Azure making your critical workload reliability decisions. Also, just want to put in a little plug that these slides and other outage themes and concepts were delivered by Sami and David at Ignite last week, and that link to both of their sessions are in chat. I highly recommend that you take a look at that. So now jumping into the slide. So Azure geographies. An Azure geography is made up of one or more regions that sit within a fixed data residency boundary. Within an Azure geography, there's at least one region that's equipped with availability zones, and we'll get into that in just a second. Next, jumping into regions. So a region is made up of one or more data centers within a fixed metro level boundary. This is how we ensure synchronous replication within a region. Now double clicking into the region, we have availability zones. So availability zones are typically designed as triplets, each being physically and logically separated group of data centers within a region. And each of these availability zones are equipped with its own independent power, cooling, and networking. They ensure high availability and resilience by reducing the risk of data center level failures. So Sami, I think you have more to say on this, so back to you.
Super, and there are many things that can go wrong. We're not going to touch on everything, but we'll pick on a few. When I think about some of the failures that can happen, we could have an operating system issue or a disk issue on a virtual machine. Broader yet, we could have an entire rack go down within a data center. That's possible. It can impact multiple virtual machines. We could have a zone issue where we lose an entire data center, or it could be even worse. We might have an entire region that is impacted because of some natural disaster or something terrible like this, and that would impact multiple DCs and zones. And in the case of like data loss or corruption, ransomware, rogue administrators, all of those things can be problems. Now, to offer some sort of, when we spoke about that middle tier, to offer some sort of resiliency levels to those things, well, for the first one, when we think about a hard drive issue or an OS issue, customers can use premium storage. It offers a 3 nines SLA, 99.9% SLA, a financially backed one. If a rack goes down, we have an availability set that customers can use. We put their VMs in availability sets, which offers 3 nines and a 5. If an entire zone goes down, customers can use virtual machine scale sets, particularly with Flex across availability zones, which offers 99.9%, so 4 nines SLAs. And worst case as well, when we think about that regional outage, customers can use something like Azure Site Recovery, and they can fail out of the region, not only into the paired region, but into a region of their choice. And when we spoke about all those pesky data issues, we have a very simple solution, which is Azure Backup. Now, these are some of the standard resiliency options that we have in Azure, and customers can go further as they kind of architect their application, and they can make different combinations and permutations of these. But making all of this real today, we're going to be looking at VMSS Flex, Virtual Machine Scale Sets Flex, a demonstration with Chaos Studio, and we're going to be using fault injections there. And to make this all real and kind of walk us through this is Dave. So Dave, welcome, and thank you very much for joining us.
Thanks, everybody. My name is David Newman. Happy to be here with you folks today. We are talking today about this idea of making sure that we can build reliable workloads inside of the Azure environment. And the first thing we have to think about is, well, what things do we have to think about? What recommendations should we be following from a reliability perspective? One of the best ways to do that is to take advantage of this tool that I've got shared here on my screen. That is the Azure Proactive Resilience Library. We like to call this thing April because it's easier to say than Azure Proactive Resilience Library. So April is a tool that's available for you. What's interesting with the April tool is that if you break this down on this left-hand side, we have a whole list of different Azure resources that are available in this menu. If we look at individual services, what we see is that we have individual recommendations that have come from the different product groups for all kinds of different services. If we look at the world of compute and look at virtual machines, for example, there are a host of recommendations that are available here that are a part of the virtual machine product team's recommendations for virtual machines inside of Azure. Notice that the very first one of these recommendations is to run production workloads on 2 or more virtual machines using Virtual Machine Scale Set Flex. And the second one, of course, is to deploy the virtual machines across availability zones. There are lots of other options that are here, but we're going to focus on these 2 today. If you want to find out if your virtual machines, for example, are currently using availability zones or not, if you don't know, there is a tool that's part of this April environment that actually creates, or that is published on Azure Resource Graph query that you can choose to run inside of your environment, and it will do a list of all of the virtual machines that are not assigned to a particular zone. So this tool is great and is available for you to use, and I would suggest that you do so as you're looking to begin the process of building out your environment for resiliency. Now, let's take a look at some virtual machines. I have a series of virtual machines that you can see here on this screen. I've got a series of web servers, 1, 2, and 3, and a series of app servers, 1, 2, 3, and 4, that have been set up so that I've now got a front end and an app environment that's tied to that front end. These individual VMs have already been, for the most part, distributed into availability zones. If we take a look at this first virtual machine, for example, this web server 01, we can see that it is in availability zone 1. If I scroll this down a little bit, it shows me that it is in this availability and scaling section, that it is part of availability zone 1. Web server 02 is in zone 2, and web server 3 is in zone 3. The app server environments are also currently distributed across availability zones. We can see app server 1 is in zone 1, app server 2 is in zone 2, app server 3 is in zone 3. App server 4, however, is not in an availability zone. If I scroll down and look at availability and scaling here, there is no availability zone. The recommendation, that number 2 recommendation from April, is to make sure that our resources are distributed across availability zones. A previous version of the one of these live streams that we did earlier this calendar year was a session where I walked through the process of how you can take an existing virtual machine that is not deployed in availability zones and migrate it to being in zones. And I'm going to preview that process really quickly today, but I'm not going to go through it in detail. You can go back and look at that previous version of our show to make that work. Now, the way that we would make this work, if this machine right now is not in any availability zone, what I would typically do, and this can be done through CLI, it can be done through PowerShell, it can be done through a number of different ways, but in the portal, I would go to availability and scaling, and I would just choose the option here that says getting started. And what it will do then is it will start this process of moving the VM to an availability zone. I then choose which zone I want this VM to go into. And I could pick any one of the 3 zones. I'm going to pick zone 2 just because I can. And we need then to grant permission to a system assigned managed identity to perform this task on our behalf. There's a process that this will go through now where it will go and it will spend some time doing some evaluation and validation of this process. And then it will eventually move the virtual machine to the zone that I have chosen. We're not going to walk this process all the way through today. We did this in a previous session. What I want to do more specifically is focus on how we can take advantage of VM scale sets and the flexible orchestration of that, and then see how we can test for this. So we'll let this run in the background and we'll switch to one of our existing systems. We do have our app servers, 1, 2, and 3, that are already in zones. But one of the things that we want to encourage customers to take advantage of, especially as you're looking to deploy larger and larger sets of virtual machines inside of your availability zones, is to put your virtual machines into virtual machine scale sets. Gives you the ability to automatically scale those resources. It also gives you a tighter connection between the update process that happens in the background to make sure that as we're making updates on the host systems, that you won't end up having more than one system affected at the same time. So the idea of scale set is an important piece. The thing that is different about the flexible orchestration model, or one of the things that's different about the flexible orchestration model versus the uniform model, which is the one that's been around for a while, is that the flexible orchestration model, as the name implies, is flexible, and it allows you to attach and detach virtual machines at will, existing virtual machines. The flexible scale set process just uses regular Azure VMs, where the uniform version of scale sets, the virtual machines exist as a subset of the virtual machine object. So we can take this existing app server that currently is not part of a scale set, and we can add it to a scale set. Now, we would need a scale set first. So let's go take a look at how we can build out a VM scale set. I have one that's here already, but we're going to build a new one for our app server. And so I need to find my, where is my resource group? Sorry. Apologize, folks. There we go. And we're going to call this thing my app VM scale set. We're going to make sure that we include all of the zones that are a part of this process. My virtual machines are deployed right now into Canada Central as a region, and so I'm going to make sure that my scale set lives in the same place. And I'm going to choose this flexible orchestration model. I'm also going to change this so that I do have options for how I want to manage scale. I can choose to manually scale this environment, so I can tell it, go spawn a new one because I say so. I can have it automatically scale based off of CPU or schedule or lots of different options. Or I can see no scaling profile at all. And this would just be for manually attaching a set of VMs after deployment. I do want to make sure that we can follow the manual process because I want you to see the rest of what this looks like. Normally, we would need to make sure, of course, that we have, as we're potentially spawning new virtual machines, and this is Windows, we need to have a local account that will work in here. We also need to have a password that will function in this space. Again. There we go. And then I can choose different options for creating the scale set. I can use spot VMs if I want to for cost savings. I can choose the kind of disks that I want to use. I then need to make sure that I also put this in the right network for the function of the portal. It always chooses to try to create a new virtual network. We don't need to do that. I want to just use my existing app tier subnet in my existing virtual network. I'm going to have this create a load balancer for me because I want to have a load balancer as a part of the process. So we're going to build a new load balancer that we're going to just call our app load balancer. And we're just going to use port 80 as a rule for ease of process for today. I'm going to go ahead and review and then just create this new flexible orchestration VM scale set. It only takes a few minutes to do this, or not even a few minutes, it takes a few seconds to do this, as it will go and build out this virtual machine scale set for us. This now gives me, again, the ability to add existing or detach existing virtual machines from this scale set as needed, and gives me that additional level of confidence that my environment will be running in a consistent fashion at all times. So what I can do is look now, I have this new app VM scale set. There currently are no instances running in this environment. So what I need to do is add my VMs. Because the virtual machines that we add to the scale set are existing virtual machines, regular Azure virtual machines, I can go to the actual virtual machine itself. If I go to this app server virtual machine, and if I come down to the left-hand side menu and I choose the option for availability and scaling, I can see here that my virtual machine is in availability zones, but it's currently not attached to any scale set. And so the recommendation here is to improve scalability by attaching to a VMSS Flex instance. And what I can do now is see that my app virtual machine scale set is available for me to attach to. So I push the attach button here, and it's just going to go ahead and attach that virtual machine. I can do the same thing with each of these app servers and attach them to my Flex environment. And we'll go ahead and do the third one as well. And attach this one. I'm not going to do 4 because 4 is still in the process of migrating, so we didn't finish that process. But what we've done here is we've gone through the process of adding these different app servers to the VMSS Flex instance that we created. So if I come back here to my VMSS Flex and I hit the refresh button, I've now attached those 3 existing Azure virtual machines to this VMSS Flex scale set. And there is a load balancer that sits behind this. Now, as I've added these VMs after the fact, they're not in the backend pool of the load balancer, so we need to go and do that. So we're going to grab the backend pool of the load balancer, and we're going to go and add those virtual machines to the backend pool, just so that we know that our app servers are going to be in that backend pool. So go ahead and save that. Oh, sorry. Oh, it's a whole backend. That's not what I wanted. Apologize, folks. I wanted to change this, and try again. Apologize. It created a brand new one for me. I didn't want that. I just wanted to add to the existing one. There we go. And we're going to go ahead now and add those VMs to the backend pool. What that means is that each of these servers now sits behind the public IP address that's been assigned to this backend pool, and I could potentially hit that virtual machine, any one of these VMs from that public IP address. Now, I actually do have inside of my environment an existing virtual machine scale set, my demo web virtual machine scale set that already has a list of instances tied to it. This list of virtual machines is actually sitting behind not a load balancer, but an application gateway. The application gateway is using this particular public IP address. If I copy that particular public IP address, and if I grab a new page in the portal and I just do an HTTP connection, because remember we picked port 80 in that process, I can see that the web server actually are up and running. So I've got web servers 1 and 2 and 3, and I can cycle through just to refresh on the page, and I can see all these are working, and that's great because they're in my VMSS Flex scale set. They're sitting behind an app gateway, and I can hit any one of these, and if one of these were to go offline, I should still be able to get to the other ones, and that shouldn't be a problem. So I said should, and in theory, that should work, right? But how do we know? How can we test it? Can we prove that in the event that one of these systems goes offline, that I can still get to my stuff? Well, we can do that. And the way that we do that is we actually test that through using Azure Chaos Studio. With Azure Chaos Studio, we have the ability to create experiments that will automatically create chaos in our environment for us intentionally. We can create intentionally injected faults into our environments to allow for us to confirm that the resiliency components that we have put in place are going to function the way that we expect them to. And so the way that we do that is we start off by defining a series of targets inside of this environment. And let me change my resource groups here to grab the right one. And so what we can see here is that for targets in here, I have a series of different targets that these were set before that we want to make sure that we can enable. And when we're choosing to enable these targets, these will be ready now for us to go and to make changes to once the process of enabling these targets exists. We have to define which systems we want to use as the guinea pigs, if you will, for our experiments. So now we've got this process finished. We're going to go back to our chaos environment. And now that we have our targets defined, what we can see is that with the targets that we've defined, the web servers, let's refresh that. So we have the ability here to manage the specific actions for these systems. I have the ability to do a VM redeploy or a VM shutdown based off of these services. Those should show as enabled. There we go. And so that's good. So what we can do now is go to do an experiment. We create a new experiment, and in that new experiment, we choose our resource group, let's go back and do this here. And this is just going to be a test experiment that we're going to run. And so then we're going to go ahead and say next. Now, the system needs permission to be able to go and do this. And you can either use a system assigned identity, or you can use a user assigned identity. I'm going to use a user assigned identity because I've created one that's that we're going to use here for this that I've got here for that is my live stream demo managed ID. This identity has already been granted the proper roles in Azure to be able to accomplish the tasks that we need. The next thing that we need to do, of course, we have step one, branch one in our process. We need to add an action to this. And we're going to add a fault. We can add faults or we can add delays. In this experiment, we're going to add a fault. And in this case, we're going to go and we're going to find the fault that's going to shut down a virtual machine. So we're going to do VM shutdown. And we're going to let this last for a little bit. Let's make this 25 minutes. I'm going to do an abrupt shutdown of the VM so it will happen quicker in this demo. I then need to pick my target. And these are the 3 machines that we targeted. And so we're going to shut down web server 1. And so we're going to add that as a fault in our process. We're going to go ahead and review and create this experiment. Once we've created this experiment, I will have the ability then to trigger this experiment, and I will be able to see the system automatically shut down that virtual machine for me. And once it does that, we should be able to see in our in the web services that web server 1 is no longer available, but web server 2 and 3 will still be. So we'll let this finish building, and then we will we'll jump in, and we'll be able to actually trigger this experiment. So let's go ahead and start it. It takes a moment for this experiment to kick up and be ready, but the advantage of these experiments as we are building them is that we can choose to build these in any fashion that we want. We can also control when these happen, how these happen, and we can use these chaos experiments to be able to, as we are doing, intentionally inject faults into our environment so that we can confirm that our resiliency is doing what it's supposed to do. All right, so my experiment is running. If we go back and look now at my list of virtual machines, if I do a refresh on this, we should see that web server 1 is now in a stopped state. So the experiment has already turned that system off. If we go back out here, and if we do, I'm just going to refresh this page. If I cycle through this now, what we'll see is that I can go back and forward between virtual machines, but as I'm refreshing, I don't get one because one's down, but everything else is still functioning. So the idea here is that we have used this chaos experiment test to confirm that even if I was to lose, in this case, a whole zone, because I had one of these VMs in a zone, I'm able to use this to simulate a zone being offline and know that my environment still is functioning, still is doing what it needs to do, is still available, is still reliable, even though I've experienced an outage, experienced a failure. So this has been a little bit of a look at how we can build out environments that will be resilient, that will be reliable, and survive a failure, and we can test to make sure that it will. Thanks, folks, and back to Sammy and Kelly.
Super. Thank you very much, Dave. Thanks for the experiment. I really like Chaos as well. And I know that the Chaos team are constantly adding fault injections to their library. So if there are fault injections or scenarios that people would like, please let us know. We'll pass on that feedback to the team. When we think about these inevitable events of outages, we don't think of our competitors as being other cloud providers or anything like this. Our competitor when it comes to outages is really on-prem, because when customers have an issue or an outage on-prem, they know what's going on, they have updates, they can understand the contributing factors that led to this. When there's an outage in the cloud, this can feel like a very different story, and we don't want it to feel like a black box. And so we've generally created these 5 guiding principles to kind of walk us through the type of experience that we want to make for outages. The first one is around speed. It has to be fast. Customers need to know, is it a me problem or is it an Azure problem? And so we've invested heavily in our AI ops to come up with this system called Brain, and Brain can notify impacted customers within 15 minutes of impact. Humans are pretty slow and the automation is pretty fast. The second one is around accuracy, but I'm going to gloss over that for now and come back to it. The third one is around discoverability. Customers have this heuristic of going to this public status page and checking to see if there's an outage. And when there's a green tick, they think that Microsoft is lying. But the majority of our outages impact such a small number of customers that we tend to target communication. And so customers configuring those Azure Service Health alerts are really useful. It can be an email, it can be an SMS, it can be a webhook into a problem management system like ServiceNow, PagerDuty, or OpsGenie. But really, the Azure Service Health alerts are a great way to get plugged up into any communication that we're sending about all impacting events. The other one is around parity. Not only parity within our communications, we want to make sure that all our services are communicating the same way, but parity across our clouds. Customers purchase the Microsoft cloud, and when they open the box, they get an Azure and M365 and a Dynamics or a Power Platform, and we want to make sure that all of that is cohesive, particularly when there's an incident that spans multiple of our cloud products. And then lastly, we want to be transparent. We want to be transparent as we can during, which means offering ETAs or when we think it, how long we think it could last, and also afterwards, with all our learnings and everything that we've learned and what we're doing about it, we want to share that. Circling back to the accuracy or granularity piece, when there is impact in the cloud and we tell customers there's an issue with virtual machines in East-to S2, if customers have hundreds or thousands of virtual machines in East-to S2, it's a problem understanding which of these virtual machines. Is it my production or is it my dev test? And that piece of information can make all the difference in how customers respond. So here to help us understand how to identify the impacted resources during an impacting event, I'm very pleased to introduce Stefan and Abhishek to help us walk us through this. Stefan, Abhishek, over to you.
Yeah, thank you, Sami. Hi, folks. My name is Stefan Kamdum, Program Manager for Azure Service Health, and I'm happy to be here. Today, we're going to demo the impacted resource feature in Azure Service Health. First, we are going to introduce the Azure Service Health, then discuss why it's important to show impacted resources in customer communication before we deep dive into the demo. Azure Service Health is a platform that provides key updates and communication to Azure customers about their services and resources. Specifically, Service Health is currently used to communicate about several event types, such as service issue, security advisory, plan maintenance, and health advisory. Service Health provides this update and comms to customers through the portal, the API, and the Azure Resource Graph. Service Health has an average of 520,000 monthly active users and more than 5 billion API calls per month. Previously, our communication capability only allowed us to communicate at the service and region level. Since the customer can have multiple subscription and tenant on Azure with thousands of resources in a region, customers maintaining these workloads were often confused and did not know exactly which resources were affected. The lack of impacted resource was a feedback that we heard consistently, as well as the frustration associated with customers having to create their workload for impact, having to check the workload for impact or create support ticket to figure out if they were affected. We address these pain points by introducing the impacted resources in Service Health. Now, customer who log into Service Health can view impacted. Next slide, Kelly. Now, customer will log into Service Health can view the impacted resources on the portal for service issue, security advisory, and plan maintenance communication. Service Health also built a new customer-facing API for customers to pull impacted resource info for an incident. Service Health also surfaces impacted resource in Azure Resource Graph so that customers can query those data. One thing to point out for service issue is that we have potential and confirmed impact. Confirmed impact are the resources that are actually impacted by the event, whereas potential impact is just a list of all resources mapped to a subscription for the impacted service and region. They may or may not be impacted. In the past 6 months, we have increased the impacted resource coverage for service issue from 45% to 60%, and for planned maintenance from 11 to 35%, whereas the coverage for security advisory has remained flat. We have initiative on the way to keep increasing the impacted resource coverage for all events to 100%. Next, my colleague Abhishek is going to demo how in the Service Health portal you can navigate to find your impacted resource affected by an event. Thank you.
Thank you, Stefan. Hello, everyone. My name is Abhishek. I'm a software engineer in Azure Service Health team here at Microsoft. Today, I'm going to walk you through how to assess your impact during an ongoing problem with your service under your subscription in Azure Cloud. Let's say I'm in the same organization as Dave. I'm a site reliability engineer or an all-con engineer. I have set up alerts on my production workloads regarding virtual machines, as Dave has set up. Now, I received an alert that there is an ongoing issue or a service event that is happening in Azure in virtual machines. Now, what do? I go here on Azure portal and I go to Service Health page. Okay, now I see one event that is shown to be impacting my subscription. Now let's click on this event and see the details. As I said, this event impacts virtual machines in Canada Central region. It falls under my same subscription under which I have production resources as they've created previously. I can see the impact, the start time, and the latest update to assess what is ongoing, what is the problem that is happening right now. Also, at the bottom of the screen, I can see what resources are impacted in my subscription. Let's click on the impacted resources to assess the impact that I'm currently expecting. Now, as a site reliability engineer, all-con engineer, I'm interested to see how my production workloads are impacted by this live service event. As I see a list of impacted resources here. I can see resource name, the current resource health, and impact type, and other resource details like resource type, resource group, and the location of these resources. Also, the resource health is the current resource health for these particular individual resources. As you can see, this web server 1 is unavailable right now. As Dave created in this chaos experiment, this was a customer initiative event, but let's assume this was a platform initiative event and something was wrong in zone 1. Now this virtual machine is unavailable and it is confirmed to be impacted, which means Azure received information that this was impacted by this live service event. The second VM that I see is currently available. Now the impact type here is potential. As Stephen mentioned, we are showing this in this list because it falls under the same resource type, which is virtual machines, and the same location, which is Canada Central, for this subscription. It may or may not be impacted. You can see the current resource health for this resource to assess the impact and assess the mitigation strategies. Also, there's a link here for, let's say, web server 1. Let's click on the link and see where it takes me. This takes me to the resource health page for this particular resource. As I can see, this is currently unavailable due to customer initiated action. And I can see the health history of this resource as well to know more. Okay, solid. Now, this resource list, impacted resources list, can also be filtered down by different subscription IDs, which I'm access to. Let's say I have multiple subscription IDs, which I'm managing as a site reliability engineer. Then I can see the subscription IDs, the impact type, or the status, the current status, the health status of these resources to assess the granular impact. Another functionality that we offer is export to CSV. The resources list can also be exported to CSV so that I can share this same list within my organization as I see fit. Okay. Now, What we have seen is basically how to see the resource impact for any service event via Service Health UI page. Now let's look at this information in a programmatic way via Resource Graph query as well. So I'm going to move to the second tab here. I go to Resource Graph Explorer. Okay, I go to the tables here and I see Service Health Resources table. I click on the table and I want to see the impacted resources for same event that we are seeing here. I'm going to paste one query to see the impacted resources. Okay, so what do we have in the query? First, we are looking for impacted resources of type events/impacted resources. We have adjusted the tracking ID here, which is the event ID, to be this tracking ID. It's the same tracking ID that we are currently having in this virtual machines Canada Central Service event. Let's try to run this query and see what it returns. Okay, so this list results me in one row, basically. Let's see the details. So as we can see, a host of details of resource group, resource type, regions across my subscriptions via Azure Resource Graph query for this particular event. Now, the good thing about this Azure Resource Graph query is I can aggregate my results across subscriptions, which I'm managing for the single tracking ID or a single service health event. In that way, I can assess the impact for multiple production workloads on my business app. Okay, so let's go back to Service Health page. Let's assume that this Service Health event is resolved. A few days later, I got another notification that there is some planned maintenance that is going on for this same virtual machine scale set, virtual machines under the same scale set for my production app. Let's look at how to assess the impact and remediate that strategy. I click on this event. Again, as same in service health event service issues, I can see the scope of the maintenance. I can see the impacted resource, services, impacted regions, impacted subscriptions. It includes the summary section also includes the last update where I can where the actions are suggested for me to take during the maintenance window or before the maintenance window. Now, same as service health events, I go to impacted resources here. Here, in the same way, I'm having a list of impacted resources that falls under this maintenance during this maintenance window. I can see web server 01 is planned to be scheduled for this maintenance window. I can see other details like resource group and the region as well. I can similarly to service health impacted resources, I can export this as a CSV as well, and I can share this with my organization. Now, let's go back to see how Resource Graph query also return the same results in a programmatic way. So let me copy this tracking ID here, which denotes this specific plan maintenance. Now I'm going to use the same Azure Resource Graph query to get the impacted resources for this maintenance event. Let me just change the tracking ID here to this one. Okay, so here, if we see the details here, I can see the impacted resources under this this new tracking ID with the same information like resource name, resource group, resource type, and the location of this resource. Another thing I wanted to highlight basically is this is a secure and auth-based workflow. It means only people who have permission to specific subscription can access or see impacted resources in this subscription. The second thing is this is also aggregatable by subscription IDs across your multiple workloads. So let's say I'm managing different subscription, I have access to different subscriptions, and different resources are under the same tracking ID and same maintenance event, then I can see them aggregatedly in the same view. That concludes my demo. Back to you, Kelly. Thank you.
Thank you very much. Thank you, Abhishek, and thank you, Stefan, as well. I just want to speak very briefly about resource health. While clearly it's a great way to understand which resources are impacted, we, Azure, have a long way to go before we get this up to the bar that we want it to be. We want customers to be able to differentiate during an outage which virtual machines have been shut down nicely and which virtual machines have been impacted because of the outage. And today, while we show that information, it's not very clear. Our goal is to really kind of develop this infrastructure so that customers know which of their resources are impacted, whether it's for planned or unplanned events. But as I said, we still have a way to go. But thank you very much for showing us kind of some of the building blocks and the infrastructure that we have. I appreciate it, both of you. And Kelly, back to you. Thank you.
Yeah, thanks, Sammy. And yes, so Abhishek and Stefan, thank you so much for showing us how to find impacted resources. Now, some of you may be asking, well, how do I find out the health of my critical workload or critical application? And in chat, you'll have a link to a segment that we did last October that Dan demoed a critical application and how leveraging Azure Application Insights to monitor and diagnose the health of that critical application. It's less than 10 minutes, so I suggest that you take a look at that. Now pivoting to security side of the house. Our CEO says security over everything, and so I'm really thrilled to introduce you to Justin, who's going to help us prepare, react, and protect our Azure resources from the latest security threats. Justin, over to you.
Thank you very much, Kelly. Good morning, everybody. My name is Justin Moorfield. I'm a Senior Technical Program Manager here in MSRC. So we run security for Microsoft. And specifically, I manage everybody's favorite process, which is actually today, Patch Tuesday. So if you're not familiar with Patch Tuesday, that's when we disclose all of our vulnerabilities and all the fixes. So I'll talk a little bit more about that here momentarily. But in essence, as Kelly had mentioned, our number one priority is security. And so we have the Secure Future Initiative, which if you haven't heard about it, well, I'm going to be the first to tell you. There's a lot of different factors that roll into SFI called pillars. And so within each of those pillars, there's a lot of different work that we're doing internally, but also it has a large bearance on how we are projecting security externally. And there's things that you all can learn from us as well. So today, specifically, as we talk about CVEs or Common Vulnerabilities and Exposures, as they're called, we're going to be honing in mostly on Pillar 6, which is accelerating response and remediation. All right. Now, once again, our goal is to try and streamline our response remediation, but at the same time, it's important for you all as customers that we're enabling you to do the same. So throughout the process of SFI, we're establishing paved paths, basically streamlined ways of going and executing a task repeatably and scalably, and then also creating standards for how those are done. So with CVEs, one of the things that we wanted to do is we wanted to reduce the ambiguity as to what you need to do when one is disclosed, how you get notified of them, especially with Azure, because we have a large ability to target notifications directly to you. And so throughout the process of developing a communication that goes directly to you all when you're affected by a CVE, this helps to streamline your mitigation, helps to get the information directly to you where it's most critical and in a place where you already look at. So one of the things that's important is kind of conceptualizing how we go about a vulnerability disclosure process. Now, this is the full life cycle leading up to disclosure of the CVE. And so this is based on an industry process. This is a federally regulated program that governs our vulnerability disclosures. Now, obviously, there are times this doesn't work out. Occasionally, a security researcher or a company will disclose a vulnerability outside of coordination with us, but those are rare occurrences. Generally speaking, we get a report from either an external researcher or one of our security teams finds a vulnerability or a product group discovers it in their product. They report that to us at Microsoft Security. Engineering and our security teams will partner together to do an investigation of it. They'll corroborate the impact, make sure that they have a full understanding of how it impacts the product and which versions it impacts. They'll go on to developing a mitigation. And then the last two pillars, deploy and disclose, those happen in parallel to each other because we deploy the fixes that you will then go and implement in your environment to protect against that vulnerability. At the same time that we disclose the CVE, which is your call to action and provides risk assessment information. So second Tuesday of the month is Patch Tuesday. This happens, it's been going on for right around 10 years now. It's very, very familiar in the world of like Windows and on-prem products. but only recently have the guidelines for CVEs allowed for us to assign a CVE to a cloud vulnerability. And this is kind of monumental because when CVEs were created, they were created in 99. The internet still made noise, and Y2K was probably one of the bigger concerns, and next to what songs you downloaded from LimeWire giving you viruses. So now that they didn't account for having cloud products, they didn't account for having services which have a shared responsibility model, and so being able to assign a vulnerability really builds consistency with how we communicate about vulnerabilities in the cloud to you all as customers. And so we'll go ahead and click over to the next slide here. And once we disclose those CVEs, they go through a new process of communications to you. So historically, we've always published the CVEs to the security update guide. This is our formal, official repository of all of our vulnerabilities that we disclose. But with Azure, we partnered with Kelly's team and to go and create a process where once we disclose that vulnerability, if you're affected by it, and assuming we have the telemetry to identify your subscription, then we will notify you directly within the portal through Service Health. So this is, once again, this is a big shift from the old paradigm of you all had to go seek out the information or subscribe to email notifications versus us being able to provide you the information directly to you on what is affected and what the vulnerability is. Let's go ahead and click over. Yeah. So there's a couple important steps. Abhishek and team had been talking about the importance of creating service health alerts. Well, the same goes for this. There's a separate type of there's a separate type of service health alert. So you can get outages, plan maintenance notifications, but there's also a security advisory. So those are the type of alerts that you'll want to configure as you're setting up your service health alerts. And I highly encourage that if there's a team specific to responding to vulnerabilities, or if there's security operations center, have those folks subscribe to those notifications. You can get them targeted directly based on the event type. And the importance of these communications is kind of lost if it's not getting to the right people. So identify who those folks are, have them subscribe to the service health alerts for security advisories, and it will greatly improve their ability to react to the latest that are coming out with threats across our ecosystems. So there's a blog that we'll provide a link on it. It gives you a little bit more detailed information on how this process works and what you need to do to really take advantage of it the best you can. But this is a great opportunity to really ease your burden of managing security within your environment, especially on days like today when we're going to be disclosing vulnerabilities. We're in a holiday time period. Everybody's trying to just focus on the things that need to matter. So it helps you prioritize and know what you need to do. Go on, next slide, please. Oh, excuse me. So I will go ahead and screen share now. So what I'm going to be doing is I'm going to be showing a demo of what it looks like when we actually publish a CVE, and then likewise, what are how does that security advisory look within the Azure portal? There we go. All right. So this is our security update guide, and there we go. This is our security update guide. This is where like I said, we publish all of our CVEs to. And CVE, you just take it if you're not super familiar, that's okay. CVE is synonymous with a vulnerability. So they're mutually exclusive to the vulnerability to each vulnerability that affects a product. And we have CVE for each one of those. And the importance of this is it provides some really critical information to help you with risk assessments. So that way, you know when you need to go and adopt a mitigation or how fast you need to react. And so I'll just quickly go over some of those key points and some of the things that we include that I think are really valuable and are still, seeking adoption across the industry for this. So, and then we'll click over and I'll show what an advisory looks like in the portal. So this was a CVE from last month. It affected Azure's database for PostgreSQL. And so the important parts I want to mention here. So CWE, this is a industry standardized method of talking about a root cause. So just as Azure LiveSite has root causes that they publish for their outages, these are an industry-wide standardized method of talking about those. So, there's tons of different reasons that a vulnerability can come into production. And so these give us just a little bit of an insight to that, right? So if you're in a security company or you're really focused on understanding the core root causes of security vulnerabilities, you can find these within our CVEs. There's a national database that includes these for other companies as well. And so it just gives you a little bit of extra data. In terms of risk assessment, the CVEs score is a standardized way of abstracting the different key aspects of a vulnerability and discussing them in a consistent manner. So the CVEs score is comprised based on these different factors here. So attack vector, it could be a couple of different things. And within the security update guide, we do provide definitions of what these things mean. And there's also there's in our collateral with the links, there's information on the rest of these, just in, the general guidance on it if you want to read more. But you can click through each one of these. It'll give you a description as to what this really means. So for instance, the attack vector was network, meaning that there's a potential that this vulnerability could have been exploited just over the open internet. However, privileges required were high, meaning that the attacker would have had to needed administrative permissions in order to exploit. So you can use some of these factors to really understand, okay, network means there's a high surface area or a large surface area for exploitation, but there's a risk mitigating factor of you need to be an admin in order to exploit it. Right? So you can take a look at these different things. So the basically from user interaction above, these are things that factors that will dictate whether or not a vulnerability is easier or more complex to exploit. And then these below, scope, confidentiality, integrity, availability, these really describe the impact of it. So you can get a better understanding. All right, high impact confidentiality, integrity, availability. Really, what is that going to implicate for your environment? How high of a risk is it? Well, with this one, luckily, because if you need to be an admin to exploit it, the chances of it being used in a malicious action are relatively lower than others. So I want to point those out. Temporal scores, this is basically explaining how mature and how prolific of how mature is the vulnerability in terms of being exploited, right? If we've detected that it's been exploitable out in the wild by threat actors, that there's wormable or there's a POC that is available for download to go and immediately weaponize it, that will all be included here as well. The exploitability data, which is really important because this isn't something that is provided at scale. Same with the CVEs score. Both of these factors are technically optional, but we want to provide them because it gives you all the best opportunity to understand that risk to your all's environment and help you prioritize what types of actions you need to take when mitigating. So if a vulnerability has been disclosed prior to us actually publishing the CVE, publicly disclosed to yes, and likewise, if we have teams that go and assess all these different vulnerabilities and they hunt around the internet, the deep web, and all these deep and dark, seedy places of the interwebs, just to try and go and find, is there anybody that's already exploited this vulnerability? Is it for sale on the dark web by some threat actor group? And if so, then we mark that as such. And that way, again, I would say this is one of the most critical pieces in understanding the risk because it will tell you, well, has somebody already used it? And additionally, if there's all peripheral information or supplemental information that we can provide about the vulnerability, right? Trying to conceptualize really what is the capability that it provides to a threat actor. How does it get exploited? What do some of these factors like the privileges being high actually mean? And so the FAQs will give you some more of that information. So then moving down, the security updates table, this is where we actually notate the different products which are affected. All right, so when you see a CVE, let's say, taking a different example, if it just says Azure virtual machines are affected, well, which SKUs of Azure virtual machines are affected? Is it all of them, just a subset? And so we will notate what SKUs or what products and what versions of those products are affected within this table. And then it links directly to the release notes so you can get a better understanding of what that update is. And historically, the security update hyperlink there, this would take you directly to where you download the update that you would implement. For most of the Azure products, because there's not always an update to download, rather you need to go and take a set of actions, in the portal or through different means of going and perform that update. We link to that information of how you perform the update. So here's, go ahead and click over here. So you can see for this one, and for instance, we had a link to how do you perform upgrades in the database. All right, and so this is just another way of trying to help get you the right information to streamline your mitigation. All right, we don't want you to have to go and hunt around if you don't need to, if we know where to point you. And likewise, you can always seek support. So I'll go ahead and click over to the Azure portal. I'm going to show you what a security advisory actually looks like for a CVE. And so we notified a subscription that was affected by, that had a resource deployed of Azure PostgreSQL with a version that was affected by that CVE. See here, I have a notification up here. That's, well, I guess my notification went away, but so so what we'll do is we'll go up and click over to Service Health, and that way I can show you the security advisory blade where that notification will be at. So just as they were showing you earlier, you have your normal Azure Service Health blades here. You can see here in the left-hand side, there's a security advisory blade. So this is where any type of security notification that is specific to your subscription is going to go. And you can see here that I have a notification for that CVE, says there's action required because I need to go and update or perform something. And we'll go ahead and click into that. So the notification that we send, we try to abstract all the critical portions of the CVE and place that into the notification so that it's more or less a one-stop shop. We try to eliminate how much you have to go back to the security update guide if we don't have to. But we basically summarize what is the score, so that we understand the risk, what actions you need to take, and then if there's any other specific information we want to include. We don't always include FAQs in here just to keep the notification concise into what action you need to take. But we do link back to the CVE in order for you to go and quickly find it. So with this specific vulnerability, you just needed to go and update the version of your PostgreSQL instance. And so one of the cooler things that we were talking about is the ability to target a notification to a subscription, and then also highlight what resources are affected by it. So we can go to details. All right, and you see it has, when I click see details, or if I go to the impacted services tab here, it shows that I have a resource which is affected by this. So I will go over now to impacted resources, and it shows this is the subscription and then the resource. So these are the key bits of information that you need to identify what resource you need to go and take an action on. So again, this is where I would then go back to this resource, and I would take a look at what the update guidance is from the CVE, or what was linked within that Service Health communication, and I would go ahead and start performing whatever action that is. In this case, I can go and update the version, and it will mitigate this vulnerability. So I will go ahead and hand off to Kelly and Sammy. Thank you all so much. I hope this was very informative. If there's any questions, please feel free to let us know.